This is quiz 1B, obviously. And the first thing I asked was the definition of a function. So f is a function if for every x there exists a y and y, so that xy is in f. And if x1 and x2, x1, y1, and x2, y2 are distinct points in f, or members of f, then x1 does not equal x2. There's actually a couple different ways to write that. The English version of that is every x gets used and no x gets used more than once, but that's not actually the full definition. You need that full definition. And you can find that full definition. Oops. You can actually find those full definitions. If you go on the Canvas site, you go here to class notes and suggested problems. And then you go down here to a new perspective on all functions or whatever it's called. You can actually see these notes right here. And those notes, one of the major advantages of these notes is it actually has the bulleted definitions in them. And there it is in red to say, hey, look, I'm an important definition. Do you have to do them verbatim? The answer is usually yes. Now, if what you say is equivalent and equivalent in a math sense, then that's fine. I recommend now, the one in the book is actually wrong. It doesn't have both conditions. It only has one of the conditions. But the one in the up here, if you look at my definitions are all bulleted, and so are my theorems. And the bulleting really helps. So I encourage you to use the bulleting. It's not so much that the definition of the book is wrong. It's just that it's incomplete from what we want. Any questions about that? Now, normally I didn't this time. That was my bad. Normally I will give you a heads up if the definition of the book is not acceptable. There's, I think, 2 more where the definition in the book is not acceptable. And then there's about 4 where I'm going to tell you, you can use the definition in the book, but you really want to use the definition in my notes because the one in my notes is easier to memorize and understand. So I will give you a heads up in the future. Okay. So has everyone absorbed the bad news about this, that this is going to be expected of you? We've all oh man, he's going to make us memorize stuff. Okay. Here's the flip side. This is the first week of class. I'm also going to allow you to do this quiz as a full credit retake. So if you messed up that definition, and it'll be posted probably tomorrow or Friday, the retake quiz. Because I have to get there's a thing that has to be done in Gradescope first. But I will let you take this quiz again for full credit. And it will be on Canvas, as I said, tomorrow or Friday, the retake. So if you bombed it, you can redo it. And this will be, barring unforeseen circumstances, this will be the last time you can do it for full credit. After this, it's half credit. That doesn't mean, I might forget to mention something major and it be on a quiz, and I might be like, dadgummit, I got to give you full credit for it. But this is the last one I'm intending to be full credit. Retakes for free. Okay. So, question 2. Write an example of a function f from x to y. I picked a1, b2. The green are alternatives that are for full credit. So you could have said for all x in x, f of x equals 1, which would have given you the points a1, b1. You could have just put this part, which you can't see. This alone was acceptable. This was acceptable. This was acceptable. A maps to 2, B maps to 1. Other things you could have done. You could have said f of A equals 1 and f of B equals 2. You could have said something like this. F of x equals 1 if x equals B, 2 if x equals A. There are 1,000 things you could have done that would have said the function. How do we feel about that? Yes, so what's in purple is the official answer. What's in orange is the partial credit answers. You'll probably get 2 or 3 points for that. Of the 4, the purple is the official answer, and kind of the green is also also full. So, how do we feel about that question 1A, 1 to 5? I'm sorry, 2A. And if someone could figure out a fast way to do these polls, I'd appreciate it. All right, so we feel kind of good about this concept. I want a set where every x is used and no x is used more than once. Okay. All right, so the next one, of course, is the same thing. Why is G not a set? Well, B wasn't used. Otherwise, you could have said not every x was used, something like that. Let me draw a little line here to delineate that this is that problem and that's that problem. Why is this one not a set, not a function? Because A was used twice. How do we feel about those last two? Dadgummit, I was hoping it would just do that. Parts B and C. You really need a TA in here, don't you? Because you need somebody to be able to do the polls while you're talking. What a clunky system. At least in Teams, you can pre-do the polls, sort of. Discord is nice, right? You do 5 poll 1 to 5, and it suddenly do. It's very nice. When 5 poll works. When pollbot works. All right. Okay, this next one. What is F's domain? Well, X. How do I know that? How do I know that the domain is 0, 1, 2, 3, 4? Yeah, I told you. Right? Right here, I told you that the domain of F, I told you that F went from X to Y, and I told you that X was 0, 1, 2, 3, 4. What was the domain of F? Well, X, or 0, 1, 2, 3, 4. This rule was valid for all real numbers, but the function wasn't. The function was only defined on 0, 1, 2, 3, 4. What is Y? What is the target? Well, the target's Y. How do I know? Well, because I told you. How do we feel about that? 1 to 5. This idea here that I'm now giving you the things. Let's see, polling. Multiple choice. 3, A and B. 1, 2, 3, 4, 5. I'll probably get really fast at that by the end of the class, won't I? Yeah. Okay. So I have 14 people in the class and 6 kind of not here. Okay, I'll live with that. Oh, a couple more people in the class. Will the domains always be expressed as X? No. In fact, that's a good question, right? If I have a set, I can have a function I can have a set A equals A, B, C, and I can have a function that goes F is a function from a to the real numbers such that f of a, such as f of x equals pi. Let's see, f of x, I'll write this as this, f of x equals pi if x equals a or x equals b, and negative 50 otherwise. Right? So what is f of c? Yeah, negative 50. Right? And so this is a function. What's the domain of this function? Well, it's a, b, c. It's the set A. What's the target? Real numbers. Yeah. Oh, yeah, I'll get to that. I made a mistake earlier in class, so that's important to know. Scott is wrong is often a valid answer. You'll see it when I post the video. You guys can go watch the video of me being wrong in the first class. Yes, that's exactly it. The domain is on the left. The target is on the right. The range you have to compute, but the domain is on the left and the target is on the right, and I'm clipping according to my little thing. Okay. Any questions about that? Okay. What is the image? Well, the image is the thing I have to compute. That's the range, right? Except I don't like the word range, even though, it'll come out of my mouth. I don't like it because sometimes you confuse range with target. I like the word image because it's unambiguous. So I compute this. So I do f of 0, f of 1, f of 2, f of 3, f of 4. And when I apply the rule, I get 0, 2, 4, 2, 3. So that makes it 0, 2, 3, 4 is the range or the image. You could also write that as y set minus the item 1 because this is the thing missing. Any questions about that? Oh, you guys have questions and I'm missing them. Yeah. Okay. All right. F is a set. So I'm going to write, 0 maps to, right here are my values, 0, 0, 1 map to 2, so that's the ordered pair, 2 map to 4, 3 map to 2, and 4 map to 3. So how do we feel about that, 1 to 5? Polling, multiple choice. Yeah, so I got these values. It's a good question. I got these. So the question is, how did I get these values, as I understand it? And the answer is I plugged in 0. So I plugged in x, and I get associated y. So that means that 0, 0 is in f. Here, I've got the fact that 1, 2 is an element of f. Because that when I plug in the number 1 as an x value, I get the number 2 back out. Okay? This tells me that 2, 4 is in f. Right? This is x, f of x, or y. Does that make sense? Okay, if you're uncomfortable with it, let's talk about it. And I'll be happy to talk about it, and I'll be happy to go over it with you because it's one of these things that is simple but hard. Okay, and calculus is full of these things. So there are things that are really hard to understand, but once you understand them, are simple. And that's actually what makes calculus so difficult as a class. Is that you kind of sit there and struggle and you struggle and you struggle and you struggle. And then once you get it, you have this bout of joy. And then like 2 days later, you're like, why was that difficult? Duh. But it's hard stuff. So if you need to make these little jumps in abstraction. So if you're having trouble with a jump, don't feel embarrassed by it. Especially if your friends are not having trouble with it, because people are going to have a difference. Now, this right here, this y minus 1 is set notation, right? So I'll just do a little note here. So let a equal 4, 8, 7. It's not in order, but who cares? B equal the set for 7. So the set A minus B equals 4 is in this one, but also in this one. So I take it out. 7 is in both. I've only got one thing in A that is not in B. So this was the set Y, 0, 1, 2, 3, 4 minus the singleton 1 as a set notation. That's just another way of saying, right? If I did, here's one from pre-calc, right? So pre-calc, the domain of 1 over x, okay? The pre-calc answer is to do negative infinity, 0, union, 0, infinity. Does everyone remember that? But I could also write it alternate. Right? I can also write this as negative infinity, infinity, removing 0. So this says all real numbers except 0. And I'm in front of it, I know. This right here says all real numbers except 0. So it's just a different way to write it. It's a good question. All right. Let's draw an arrow diagram. Well, this is 0. So this is my x space. And this is my y space. And I would write these. These are good things to write. They're not required, but we're going to have compositions of functions where we're going from u to v to x to y, or from x to y to z. I even said z that time and not z. I'm making progress. But we're going to have all of these different spaces. We're going to have an x space, a y space, and then we're going to have dy dx space, which is going to be also weird. And that's going to do different things. So we kind of want to keep track of what spaces we're talking about. So that's why I have here x space, y space. That's why I've labeled them. My x's are 0, 1, 2, 3, 4. My y's are 0, 1, 2, 3, 4. 0 maps to 0, 1 maps to 2, 2 maps to 4, right? I'm just reading it off. 3 maps to 2, 4 yields 3. How do we feel about that little arrow diagram, 1 to 5? Multiple choice. Arrow diagram. 1, 2, 3, 4. Could you imagine having to teach this class without teach an online class without being able to type? Oh my goodness. I was just thinking that. That'd be horrible. Okay. So that's just a little arrow diagram. If you're having trouble with that, by all means, come see me during office hours. Let's talk. I want you to be comfortable with that notation because it's actually very, very useful. Okay. Draw the graph of f. All right, well, the line. I'll get to the line in just a moment. 0, 0, 1, 2, 2, 4, 3, 2, 4, 3. Why did I not draw the line? What does the line say? Yes, and if I drew a line here, if I draw this line, what does the line say? The line says that there is an f of 1/2. Right? The line says that f of 1/2 equals 1. But is 1/2 in my domain? Right. So they got to go. And all you're left with is points. Now, there are ways of doing visualizations where you actually tell the person, hey, I'm filling in this gaps in the middle of the domain, but the line, I understand there's not actually a line, but the line is technically wrong in the context of this problem. Sometimes if X is something like the rational numbers, you'll actually include the line, and you'll mention the fact that you're only dealing with the rational numbers. Where you've only defined it. Yeah, stuff that's dense like that, especially. Okay. So how do we feel about that little graph thing, 1 to 5? All right. Okay. State, no need to justify. The northiness associated with pi over 2 is 1. Everybody good on that? The eastiness associated with pi over 2 is 0. The tangent of pi over 4 is 1. How do we feel about those three little values, 1 to 5? Okay. The trig I expect you to be able to do off the top of your head are these points here. Let's see. Pi over 2, pi over 4. And they're symmetric points, i.e., I want you to know this point here, this point here, this point here, this point here, this point here. I actually don't even want you to know all of them. I want you to know pi over 4, pi. I don't actually care if you know the tangents of those. I do care. I shouldn't say that. I'm just saying this is historically what has been asked on a test. Historically, those are the 5 values that you need to know: sine, tangent, and cosine for. Off the top of your head. Does that make sense? Everyone feel okay with that? I'm asking you to know. I'm going to ask you to know some more trig. We're going to need some more intuition on trig. But these are the points that I want you to know without thinking. Or, just be able to have at your beck and call. Now, that doesn't mean that you don't need to draw a little diagram. Heck, I need to draw a diagram every time I do them. I don't have... If someone says, what is the sine of pi over 2? I have to sit there, do the thing in my head, and I go, oh, let's see. That's the northy coordinate. It's northiness, 1. Right? Or even better, I draw this. So if you find that it's you have to do that, that's perfectly fine. But you do need to be able to come up with those values fairly quickly, without looking at a calculator. Just out of curiosity, what is the sine of pi over 4? Somebody put it in chat. What is the sine of pi over 4? Root 2 over 2. That's the pre-calc answer. It's a good answer to come up with off the top of your head. I love that you were able to do it. Okay? That's the pre-calc answer. The problem with this answer is it doesn't say where it comes from. It doesn't beg the question. The calc answer is the square root of 1/2. And the reason why this answer is better than this answer is because this begs the question, why is it square root of 1/2? Now, I can convert it, right? The square root of 1/2 equals the square root of equals 1 over the square root of 2, which is the same thing as 1 over the square root of 2 times 1. And 1 here is written as root 2 over root 2, which is the same thing as root 2 over 2, okay? But this is something that you memorize. This is something that you understand. What do I mean by that? Okay, square root of root 2 over 2. You see that, and it just doesn't say where it comes from. Square root of 1/2. Where does the square root of 1/2 come from? Well, let's see. If I squared 1/2 and then added another square of 1/2, what would I come up with? I'm sorry, if I squared the square root of 1/2 and then I added the square of the square root of 1/2, what would I come up with? What would be the answer to that problem? This is not a trick question. I actually want to know. 1. And that's interesting, isn't it? What does this look like? Where do you think this number came from? The square root of 1/2. That begs the question, why? Yeah, so it's either like it's Pythagoras, right? That's why. This is the why. This begs the question. Where did that come from? Well, let's look. Where does it come from? I go up pi over 4. Now, remember that, I don't know if you had Robert, he mentions this, but I don't know who was your pre-calc instructor, but a radian is actually a distance. While a degree is an angle. Now, they're equivalent. I can sub one for the other, but when I'm thinking about radians, I'm actually thinking about the length of this arc, right? Because if this is a circle of radius 1, if this is a circle with radius 1, what's the circumference of that circle? Well, it's the diameter, it's pi times the diameter, which is twice the radius, right? So the circumference of the circle, the actual distance around this circle, if this was a running track, the runner would run 2 pi, whatever that unit is, right? So if this thing was 1 football field in length, all the way around here would be 6.28 football field. I'm sorry, 6.28 football fields, or 628 yards would be the distance around the circle. Okay. Now, if the person is only going pi over 4, the question is, what is his northiness and what is his eastiness? Well, this is 45 degrees, half of 90. And this is 90, and the sides of a triangle must add up to 180. I'm sorry, the angles of a triangle, some of the angles, must be 180. That means this other angle is 45. And this is a right triangle, and because it's a right triangle, a squared plus b squared equals c squared, which is 1. So how do we feel about that, 1 to 5? How do we feel about those steps to kind of get at this, 1 to 5? I've got a right triangle, and it's a 45, 45, 90 right triangle that's going to be formed here. All right, so I have a 45, 45, 90, 45, 45, 90 triangle. That means that the triangle is isosceles. So this is a triangle that's isosceles. These two angles are equal, but that also means that these two sides are equal. Hence, A equals B. If I combine these two statements, I've got A squared plus B squared equals 1, and I've got A equals B. I substitute this A in for this B, and I get A squared plus A squared equals 1, which is 2A squared equals 1. Okay, divide both sides by 2, and I wind up with A squared equals 1/2. I take the square root, and I wind up with A equals the square root of 1/2, which means B was also the square root of 1/2 because they're equal. So that means that this length here, the eastiness, the cosine, is the square root of 1/2, and the northiness here, which is the sine, is the square root of 1/2. So really, sine of pi over 4 equals square root of 1/2 is a better answer, because it tells me where it came from. How do we feel about that? So this right here is an answer you understand. Does that make sense? The square root of 1/2 as the sine of pi over 4 is an answer that's understood. This root 2 over 2 garbage is something that you memorize. Okay? One of these you understand, and one of these you memorize. Now, that's not to say that the radicalization is not useful. It is, right? Because you might want to get all your radicals on top and no radicals on the bottom, so you can play with the radicals on top without denominators, right? That's a legitimate thing to do. But it's not a legitimate place to start. And really, when you want the answer that begs the question, why? And that's what that does. That answer, square root of 1/2, begs the question, why? Yes, you have a question.